Yeah, so our solution is data simulation, and with data simulation we combine measurement data and simulation models. So you know simulation models in a way, for example, also from weather forecasts. No, with models we predict environmental conditions, and this can, for example, be soil moisture. It can be the status of the plant, how much crop yield, and so on. But these predictions are not perfect. So we have always errors in these models. But on the other hand, we have also data, and we can combine then the measurement data, where we have the precise information, with the models to improve those models, so that with the models we can have better predictions. So predictions which are as close as possible to reality. Yes, so our site is Sellhausen in Germany, and at this site we have a lot of measurement equipment available. So soil moisture measurements are made at different depths and at different locations. We have also different types of soil moisture measurements. We measure the exchange of water and energy and carbon and nitrogen between the land and the atmosphere. We monitor the crops and how the crops develop in terms of what we call leaf area index. So there's a lot of information. And so this means that at this site we can then precisely evaluate the data simulation. We can use the data and then also evaluate with other data to which degree the data assimilation really helps to improve our model predictions. Yeah, so we think that information is very important, for example, for farmers, but also for water boards and agricultural boards. And so combining on one hand simulation models and on the other hand as much as possible all the information that we have, not only the measurements on the ground but also the remote sensing measurements, can give us the best possible characterization of the state in the fields, and also together with weather forecasts predict the evolution for the next weeks or even months. So that we can better predict the yields, we can better predict if we need irrigation or if we need drainage. And so this large amount of information can be used then by the farmers to make better decisions. Yeah, so we developed this solution in terms of software development. So we have simulation models, and also we prepare software to do the data assimilation, and this will be available to the public. So we have open source software, but we have also to admit that maybe only consultancies could use this software because it's highly complicated. We cannot expect that a farmer is running the software. But we hope also that in the future there will be a spin-off, and that a consultancy will work with this software and as a product can provide information or forecasts. On the other hand, we do also for certain sites in Germany, we do already these forecasts, and these will also be available via the internet. So for example, for our Sellhausen site, at the end of the project, people can click and see what is the predicted evolution of groundwater levels, of the plant status, of soil moisture, and these predictions will be available online, and they will also continue after the project. So these are two examples. Yeah, so this is for the farmers, so that they have more information which they can use to make better predictions, and often they are also really interested in information. They like, for example, to see on the internet, on the phone, so what is the situation in the different fields that I have. So this fulfills already a purpose. But it's also for the, let's say, authorities that act on a larger scale, like water boards and agricultural boards, or even regional government. This information is also of interest. Yeah. And the data assimilation solution can then also be used for better decisions. So it's then linked to the other solutions in WATERAGRI, like for example drainage control, real-time drainage control, irrigation, because those, let's say, other solutions can be based on a better databases, which is provided by the data assimilation.